Hello everyone, this is Aishwarya Parikar. I'm student of Sri Venkateshwara College of Engineering. I'm currently pursuing my engineering and basic science department. Today's topic for the video has been chosen from the course Introduction to Civil Engineering. Today's topic for the video is problems on Centroid. Let us begin with the video. Centroid. First, let us know what is the definition of centroid. Centroid is a point where the whole area of the plane figure is assumed to be concentrated. The calculation of centroid means the determination of x bar and y bar as shown below. You can see here in this figure, x bar is the centroidal distance from the y-axis, and y bar is the centroidal distance of centroid from the x-axis. First, let us know what are the steps to calculate the centroid. First, we have to identify the given reference axis, and then if the reference axis is not given, consider the bottommost part of the figure as x-axis and the leftmost part as the figure as the y-axis, and check for the symmetry of the figure. If the figure is symmetrical, x bar and y bar, calculating x bar and y bar is much easier. If the figure is symmetrical about its vertical axis, then x bar is equal to total width of figure by 2. And then similarly, if the figure is symmetrical along horizontal axis, y bar is equal to total depth of the figure by 2. If the figure is not symmetrical, then divide the composite section into non-geometrical figures like square, semicircles, triangles, rectangle, etc. And then determine the centroid using the following table. First, we divide the figure into components and then find the area of that component. Then we'll find out the centroidal distance using the formulas. Then calculate, multiply area into x bar, x and y. That is centroidal distance. That's when we get moment of area about x-axis and moment of area about y-axis. So these are the basic formulas which we need to know before getting into solving the problems. For the rectangle, the area is b into d, that is breadth into depth, and x bar is calculated by b by 2, y bar is d by 2, and this is the figure. Triangle, it is 1 by 2 into breadth into depth, the area, and centroidal distance is same as the rectangle, b by 2. Yeah, and y bar is 1 by 3 d. If it is right angle triangle, then it is b by 3 for x bar and d by 3 for y bar. Yeah, it is given here. And circle is pi r square, and the centroidal distance is x bar is r and y bar is also r, but it differs for semicircle and quadrant, which are mentioned below. Let us get into solving the problem. Yeah, this is the question. Determine the position of centroid from the lamina with a circular cutout. Like we have to calculate the centroid position of centroid of the shaded area except for the unshaded area. First, we have to divide this total figure into known components, and then subtract the unshaded area and add the shaded areas. Let us get into it. So, yeah, we have the figure for which we have to find the centroidal distance. First, we'll divide this entire figure into three known components, which is first one is rectangle, second one would be our triangle, the unshaded part, and the semicircle, which is also the unshaded part. We have to subtract these two components, that is semicircle and triangle, from the entire rectangle. So let us begin with the solution. First, for the rectangle, the area is breadth into depth. which is 1200 is the breadth, and depth of the figure is 1000, which is multiplied, and the value is mentioned here. And the centroidal distance from y-axis, that is x, is breadth by 2, it is 600. Centroidal distance from x-axis, which is y in millimeter, would be 1000 by 2, which is 500. 1000 is our depth of the rectangle, and moment of area about x-axis is nothing but x into area, which is mentioned here, and moment of area about y-axis is nothing but x into area. This one is y into area. So yeah, and the next one is triangle. Triangle area for triangle is breadth into depth by 2, which is whereas our breadth is 200, depth is 1000, and which is divided by 2. And the centroidal distance from y-axis, that is x, is 800 plus 2 into 400 by 3. For the triangle we have to find the centroidal distance from y-axis. Y-axis is here, and the figure, the centroidal distance of the figure is this one. The centroid would be here somewhere, and this would be our centroidal distance of the figure. But we have to find the centroidal distance from the y-axis. So we add this measurement, which is mentioned here. It is 800. So it will be 800 plus 2 into 400 by 3. And centroidal distance from x-axis, that is y, is 1000 by 3. 1000 is our height of the triangle. This would be our centroidal distance from x-axis for the triangle. And moment of area is again multiplication of area and the centroidal distance for both of these. Semicircle, for semicircle, again for semicircle we have to subtract this part of the area from this entire rectangle, and because of which we have taken minus. It is pi r square by 2. Pi we take it as 3.4142, sorry, and r value is our 400, which is squared by 2, and its value comes out in minus. And the semicircle centroidal distance from x-axis is 800 by 2. Here the semicircle is very like is connected to the x-axis and y-axis, so we need not add any external value. So the formula for the centroidal distance from x-axis is 4r by 3 pi, which is 169.765, and the moment of area for both of the x-axis and the y-axis is again the multiplication of area into centroidal distance of the respective axis, which we have found here. And then we add the moment of area about x-axis and then the moment of area about y-axis. So this is the basic table we need to be clear with. Let us go with the next step. Yeah, so x bar and y bar formula is summation of ax, that is area about x-axis by summation of a, that is the sum of all the areas. Summation of ax is 406,135,701.75, and summation of a is 748,672.59. And on dividing this, we get the centroidal distance, which is 542.474 millimeter. And y bar is again similar to x bar, whose formula is summation of ay by summation a. Ay value is 490,666.67 divided by 748,672.49, and y bar is 655.382 millimeter. Yeah, so these are the values we get for the x bar and y bar. These are the centroidal distance from the x axis and the y axis of the figure. So this would be our problem for the today's video. Yeah, so thank you for watching the video. I hope you guys like the video. Please like, share, and subscribe the video. Thank you.